go.
What do you mean you didn't? Oh, you didn't. You didn't. I thought you were going to go and at least watch or something.
No,
No.
I had a band practice with Red Fountain's band.
Oh well, there you go. See, it was something rock and roll, and it was going to be.
Yeah, it was, but it's kind of rock and roll or sort of alternative folk.
Indeed. Hey, well, so this morning we're going to freestyle on basically the meaning of life, really, essentially. The size of the universe.
Doesn't everything sort of come back to the meaning of life in some way?
Indeed. So the size of the universe. Now there are various theories on whether or not it's a open universe, goes on forever, or closed, or is that being too simplistic?
No, that's pretty much it. This is sort of sparked off by an article I saw on Universe today, where some new researchers come in saying, there are all these crazy theories about what the universe might be like. Open, closed, curved, flat, whatever. I'll describe what those mean in a second. But these guys, some researchers from the UK, have decided to apply the Occam's razor principle, which means the Occam's razor is a philosophical thing to shave away anything unnecessary, and that the simplest thing is usually correct. So they've kind of re-looked at the Hubble data and the expansion of the universe, and they've said that, well, if you apply Occam's razor, then the data does actually support a simple, flat, expanding but infinite universe.
Okay.
And this is no sort of groundbreaking discovery. It's just someone's theory, really, and there are almost countless opposing theories.
Yeah.
But to me, it seems that what they're saying is the space just goes on and on in each direction, and it essentially goes on forever. And personally, something going on forever is very hard for me to conceptualize.
Well, it's hard for the human mind to consider or think about. It's almost like, well, what came before the Big Bang? And your mind goes, oh, I can't think about that.
Yeah. Or you think of infinity, something not stopping, and then that's hard enough. But then if you think of orders of infinity, so that infinity happening in an infinite number of directions, it's sort of, that's when it starts to get even more mind-boggling. But then you think, why should infinite orders of infinity be less perceptive than just one old straight infinity?
Yeah. And
anyway, so
are we talking about on all directions as well, or was this theory on a plane of some kind?
No, this is in all directions, but that is a flat universe theory, and this all ties into the strange concept of space itself being curved, or Einstein's general relativity, where Einstein did the calculations that said that space itself, is not flat. It's kind of curved into a fourth dimension, and that's why we have things like gravitational microlensing that help us discover planets, and you have gravity wells of heavy objects. So there's a proven fact, and this is thought to be what's responsible for different areas of the universe seeming to be expanding at different rates.
Can you explain the fourth dimension?
No.
Damn it! Why not?
I'm sure Einstein could, but I think there are very few people in the world that actually really know what he was on about. But we kind of don't need to, because the mathematical proof is there and the physical evidence is there. Numerous experiments have been carried out to prove his general relativity theory.
So there's probably no simplistic way, but if you're saying different parts of the universe are expanding at different times or different rates, does that mean it's like can we think of it as a big ball, but it's got like lots of it's uneven, it's spiky, it's got bits coming out of it?
It's expanding, but there is no center because space itself was created at the time of the Big Bang, so there's no center of the universe with everything expanding out. Everything's just moving away from everything at comparable rates. It's been compared to things on the surface of a balloon. So as you blow up the balloon, every dot on the surface is getting further away from each other. That's quite a rough comparison, actually, but
What about the idea, though, that our thoughts about what everything is. That that the Big Bang existed next to another Big Bang somewhere else, in someone else's reality.
Yeah, well, that ties into this orders of infinity theory of a multiverse, where more and more cosmologists are coming around to think that the universe is not just the universe we see, but every single event, every single decision that gets made, it actually creates another universe. So there are in fact infinite other universes where every possibility could happen.
The old sliding doors thing.
Yeah, and as ridiculous as that seems, it's becoming more popular in cosmology. But you got two basic schools of thought about the universe, because we can see it expanding. So there's open universe theory, where it just expands forever, and it just gets bigger and bigger, and the galaxies eventually lose all visual contact with each other, and wait till all the energy just dissipates and everything dies, basically. And then you've got closed universe theory, which says that the mass of the stuff in the universe is enough, that has got enough gravity that will eventually slow down the expansion and pull everything back in. And that kind of gives rise to the cyclic view of the universe, where eventually everything will be back in one point, where the Big Bang happened, and so they call that the Big Crunch.
In 10 seconds or less, can you sum up what existed before the Big Bang? Go.
Well, the answer to that would be no.
Has anyone got a theory on that at all?
The theories that come forth from the people who do the calculations and know about this stuff, they say that time came into being at the same time as space. So it's kind of an irrelevant question, because there was no time, so there was no before the Big Bang. Weird, I know.
The mind cannot cope with that.
And it almost sounds like a fob-off answer, doesn't it? But that's what Big Bang scientists say.
Okay, all right. Well, we will ponder that, I suppose, over the weekend.
You can get into a kind of loop of infinite regression, even just trying to think about it.
Yeah, exactly. I tell you what, why not go to the Auckland Stardome Observatory over the weekend and stare at our past and our fate in the night sky, perhaps, and consider it. Anything else on at the Stardome we should be aware of?
Yeah, well, there's a good show on at 7 o'clock, which is called We Are Astronomers, which basically describes what astronomers do, because I think a lot of people don't really have a concept of what astronomers do. It's not sort of someone outside in their backyard peering through a telescope. It's a very, very high-tech world with all people all around the world connected to each other. So it kind of it goes into what's happening in astronomy research, and it's produced by this UK crowd, and it's got excellent graphics and, of course, the immersive theatre effect, which caused a few people to get a little bit motion sick. But it's a really cool show. It's got music by a New Zealander, in fact, Rian Sheehan from Wellington.
Oh, cool.
Did the soundtrack to it. So that's a show I'd thoroughly recommend. That's at 7 o'clock at Stardome. 7 o'clock every night except Monday and Tuesday.
And if the Stardome is out of reach, I thoroughly recommend perhaps getting on a hill somewhere, lying back on your back, and with an MP3 of Carl Sagan pumping through the Walkman or something.
Or Rian Sheehan.
Yeah.
Rian Sheehan's latest album, that would do. That's not me whining, by the way. That's my dog sitting here wanting to go for a walk.
Good. Well, I'll let you go and do that. Thanks very much, Dylan.
Yes, thanks, Wammo.
Dylan Storey.